All right, good morning, everybody. Let's do this precalculus. So today we'll be in lesson 8, complex number division. The page is S.27, and let's just look at this before we actually go through this. What's the game plan today? Students determine the modulus and conjugate of a complex number. So this we're familiar with, this we're kind of familiar with, and I'll go through it with you step by step. And then the second part of this video, we'll talk about how to divide complex numbers, okay? So just a quick review from last week, from the last chapter. If you have some complex number, a plus bi, what was the multiplicative inverse of that complex number? We use this formula, right? What does it mean to be a multiplicative inverse? That if I say, like 8 times what number is 1, that would have been 1 over 8. Or negative 1 over 4 times some number, it's 1, it would just be negative 4. Or negative 1 over 5. You're just taking the reciprocal, right? But before we couldn't do that. We needed to use this little rhythm to find the multiplicative inverse. So for example, what is the multiplicative inverse of 5 plus 7i? What did we do? The top was always what? Just the conjugate, right? So you just take the complex conjugate of 5 plus 7i, which is 5 minus 7i, right? And then what was on the bottom? A squared plus b squared. My a is 5 and my b is 7. So I'm just doing 5 squared plus 7 squared. And that was equal to what? Well, let's see. The top is still 5 plus 7i. And then what was on the bottom? Let's just zoom in real quick. What was on the bottom? It was 25 plus 49, and that's just equal to 5 plus 7i over, what is this, 54, 74, right? But then you would split it, right? This would be 5 over 74 plus 7 over 74i, okay? And this represented the multiplicative inverse of 5 plus 7i. If I take this 5 plus 7i times this, I get 1. Okay? That's what it meant. All right, everybody. What I want you to do is here, go through A, B, and C. And what is it asking you to do? It's asking you to find the multiplicative inverse of each complex number. So the same thing we just did here with 5 plus 7i, I want you to do it for A, B, and C. And then for the next part here, it's telling us to do what? It says, find the conjugate and plot the complex number and its conjugate in the complex plane. So if we look at the first one together, if I have 3 plus 4i, what is the conjugate? It's just 3 minus 4i. And then what is it telling you to do? It says, plot the complex number. So 3 plus 4i is where? 3 plus 4i is right here. So that's 3 plus 4i. And then where is 3 minus 4i? It's right here. This is 3 minus 4i. And what they want you to do is label the conjugate with a prime symbol. So you see, if a is 3 plus 4i, so this is a. What is a prime symbol? You're just doing this. A prime. Okay? B. What is b prime? C prime, d prime. Okay? Once you finish this, I want you to come to the video. I know you can do this by yourself, and what I'll do is I'll pause the video and then I'll show the solutions, okay? Okay, have fun. What's the multiplicative inverse of all 3 of these? Here are your solutions, okay? Take your time and look at them, and if you have any questions, you could ask me or ask a neighbor. So you got this. Here, for this part, if I have 3 plus 4i, the conjugate is 3 minus 4i, so this is 3 plus 4i, 3 minus 4i. Negative 2 minus i, negative 2 minus i is right here. This is negative 2 plus i. So this is my b, this is my b prime. Let's look at c prime, c and c prime. So the multiplicative inverse is just the same thing. They're the same point. It's just 7. Because this is 7 plus 0i, and the conjugate is 7 minus 0i. 0 plus 4i, 0 minus 4i. So this is 0 plus 4i, and then this would be 0 minus 4i. So the question we should ask ourselves is, here, what is the geometric effect of taking the conjugate of a complex, oh, sorry, wow, that was a failure. Let's try that again. What is the geometric effect of taking the conjugate of a complex number? So if I have some 3 plus 4i, which is over here, what is the geometric effect of being the conjugate, which is 3 minus 4i? If I have 0 plus 4i, what's the conjugate of taking, what's the geometric effect of taking the conjugate? Here I have 0 minus 4i. Okay? And the second deeper level question is, what can you say about the conjugate of a complex number? So this one's a little straightforward to understand. This one will be easy once I show it to you. Okay? And before you answer these questions, let's just take a look at this. The new way we're going to show a conjugate is through this. If z is equal to a plus bi, its conjugate is denoted as z bar. The way we're going to show conjugate from now on is z bar is a minus bi. So here, like if I just say if z is 5 minus 8i, what does z bar equal? You're just saying the conjugate. So it's just 5, oh, sorry, this is not working. Let me get another one. This will be 5 plus 8i. This is just the symbol we're going to show for conjugate. Okay, like if this is w, what's w bar? It's just minus 5 minus 8i. You're just taking the conjugate, okay? What I want you to do is take a second and try and think about this. What is the geometric effect? What's happening is there's a reflection. Like, think of this as the line. There's a reflection. If this is b, b prime, d, d prime, a prime. The conjugate, they're reflecting off each other with the x-axis, okay? So that would be a nice thing to write here. The geometric effect is a reflection along the x-axis. Okay? Now let's look at this one here. What can you say about the conjugate of the conjugate? Well, let's say if z is equal to, I don't know, 4 plus 3i, right? Well, what's the conjugate? It's z bar, and that's 4 minus 3i. Well, imagine if I take z bar and I take the conjugate again, z bar bar. Well, what's the conjugate of 4 minus 3i? It's just 4 plus 3i. So it just goes back to the original. And if you think about it, it's like, take the conjugate, you reflect. Take the conjugate, you reflect. Take the conjugate, you reflect. You just, every time you take the conjugate, you're reflecting across the x-axis. Okie dokie. All right, to get to the main lesson for today is what is the modulus of a complex number, okay? So here, let's take a look. This will be very short. And we kind of already did this. The modulus of a complex number of a plus bi is the square root of a squared plus b squared. So what does this mean? The modulus represents the distance from the origin to the point a plus bi in the complex plane. And it's denoted with this symbol, okay? Let's just look at an example together. If I say, let z equal 3 plus 4i, all right? Well, where is 3 plus 4i? This is 3 plus 4i. It's right here. And my question is, this symbol, the modulus of z, it represents the distance from the origin. So what is this? If this is my origin, what is the distance from here to here? And notice, we showed this before, but just to take a look at it again, here, what are you making? You're making some sort of triangle. And notice that, what is the distance from here to here? It's 3. What's the distance from here to here? Notice, it's 4. And what's a very famous formula we could use if we have a right triangle? We can say that this is A, this is B, this is C. we can say a squared plus b squared has to equal c squared. So here, the value of this c is just equal to, you see, how do I get c by itself? Square root, and here, c is equal to the square root of a squared plus b squared, but that is just this. These two are the same thing, and that's how we find it in the complex plane. You're just taking the distance from here to here, okay? And what would be the distance from here to here? Well, let's see, you're just taking the square root of, let's follow the formula, a squared. Well, this is my a, and that's my b, so it's just 3 squared plus 4 squared, that's equal to 9 plus 16, which is equal to the square root of 25, which is equal to 5. Okay? And that's it. What I want you to do is try and practice some of these problems over here, 5 to 8, and then I'll show you in part 2 how to do the next part. Okie dokie, enjoy.